Okay, so today we're looking at another problem that involves ratios, rates, and a directly proportional relationship. And just by looking at this graph, we know that it represents a directly proportional relationship, which can also be called a direct variation, because the graph actually passes through the origin. It passes through the point 0, 0. The points on the line form a straight line, meaning that we know that the change in one variable is directly related to the change in the other variable. And you're going to understand this as we go through this question. So let's look at the question. A standard punch requires 2 cans of orange juice and a bottle of ginger ale. So to make this punch, we are looking at a ratio of ginger ale and orange juice. So let's write that here. Ginger ale to orange juice. We have a ratio of ginger ale to orange juice. So for every 1 bottle of ginger ale, we need 2 cans of orange juice. Our ratio is 1 to 2 of ginger ale to orange juice. The question says, how many cans of orange juice are needed for the punch when using 4 bottles of ginger ale? So we're going to write this, I'm going to show you a variety of ways of solving this. We're going to write this first as a fraction, okay? 1 over 2 is what we're looking at for ginger ale to orange juice. And the question says, when using 4 bottles of ginger ale, how many cans of orange juice do we need? Well, that's what's unknown. Now, we can get the information from the graph, but we're going to solve this first using algebra. These equations are equal to each other because as we're increasing the amount of ginger ale, we must increase the amount of orange juice by the same rate. So we can solve this by cross multiplication. 1 times x is 1x, and 2 times 4 is 8. Therefore, if we have 4 bottles of ginger ale, we need 8 cans of orange juice because, as we just found, 4 over 8 equals 1 over 2. These are equal to each other. They're equivalent fractions. We can also check to see if this is true looking at the points on the graph. Well, we've already talked about that. We know that one of the points is located at 0, 0. If we don't have any ginger ale, we don't use any orange juice, we don't have any punch. The next point is located at 1 and 2. For every 1 bottle of ginger ale, we need 2 cans of orange juice, and that's what we were told in the question. 2 bottles, we need 4 cans of orange juice. 3 bottles, we need 6 cans of orange juice, and 4 bottles, we need 8 cans of orange juice. This is increasing by the same amount. Okay, we can also find the rate of change, the first differences. Well, 2 take away 0 is 2. 4 take away 2 is 2. 6 take away 4 is 2. And 8 take away 6 is also 2. Therefore, we know that the first differences are 2, which also represent our rate of change. The rate at which this is changing is by 2. So every time we have a can of ginger ale, we need 2 cans of orange juice. As we add another can of ginger ale, we must add another 2 cans of orange juice. The question said if we have 4 cans of ginger ale, how much orange juice do we need? Well, every time we add a can, we add 2 cans of orange juice. And we can see from this diagram, altogether, we will need 2, 4, 6, 8 cans of orange juice for every 4 bottles of ginger ale. And we saw from our table, as ginger ale increases by 1, as x increases by 1, our y values increase by 2. The orange juice increases by 2. And we can add this last point to our graph. We can go back to the graph. It's already here, 1, 2, 3, 4. For 4 bottles of ginger ale, we need 8 cans. You can see this point on the graph. 8 cans of orange juice. So we've just solved the problem. We need 8 cans of orange juice for the punch.
Made with Doodlecast Pro.